these three web pages give you an overview of different cations and ions, and some of the names. And I'm going to highlight in the next couple of slides a few of them that I think I don't expect you to remember or to know by heart, but it's nice that you get familiar with the name. So when I use the word nitrate, or when somebody uses the word nitrate or sulfate, or you're reading about hydrogen phosphates, or you're reading about hydrogen carbonates or carbonates, you have a general idea in your mind of what ions, what ions we are talking about. So this first slide is from the University of Western Oregon that I've mentioned in the previous slide, and this is just some typical ions that elements in the periodic table form. And as you can see, you have on the left hand side and way into this corner, give or take. Yes, you will see that, well, first of all, you will see that the noble gases do not form ions. It's not something that they particularly like reacting. That's what they call noble gases. They are very unreactive. Their electronic needs are already complete. They don't need to go around reacting to complete to meet their electronic needs. They already can do that by themselves. And you've got the elements in the top right hand corner of the periodic table, where the nitrogen, oxygen, fluorine, the non-metals, they are anions. And typically, if you look at the first, the group of the halogens with fluorine, chlorine, bromine, iodine, and astatine, you've got a -1. So they form a -1 ion. The group of the oxygen, sulfur, selenium, tellurium, they become negatively charged, but with 2 negative charges. And then you've got a nitrogen, phosphorus, and arsenic that are not particularly like becoming charged, and we will look at it later. But when they become negatively charged, they gain 3 negative charges. So they become nitrogen with gain 3 electrons, so phosphorus having gained 3 electrons. Then you look at all the left hand side of the periodic table, and you can see that some atoms, like for example in the first and second period, there is one ion, they are positive ions, and there is one ion that they particularly like to form, and that is because losing that electron meets their electronic needs. It makes their outer shell more complete, and it makes it more stable. The second group, they're called earth alkanes, the group with selenium, magnesium, calcium, etc. They form positive ions, cations, but with 2 positive charges. Then you have very interesting section, which is the periodic table in the middle, which is what we call the transition metals. And that is when you have elements that have electrons in d orbitals. And you have 5 d orbitals, and you can have up to 10 electrons. And you will see that these are only the most common ionic states. Some of those elements can achieve quite a few others. These are just the most stable and the most common ones. And you can see that it varies. They can have more than one cation that is stabilized. And we will look into this further down the line. It gives a much more richer chemistry. And what is the reasons why the transition metal elements have so many compounds, because that regions have the ability of losing 1, 2, 3, 4 electrons in different depending on what they are reacting with. This page is from Chemistry LibreText and gives you is an example of typical ions that if you are in an environmental, geological context, you are going to come across over and over again, and it's worth being familiar with. So the cations are all very straightforward because their name is simply the name of the metal with the name ion attached. So the first one is sodium ion, the second one is potassium ion. The third one, hydrogen, this is extremely important, is the hydrogen ion. And be mindful, because some people, and it's very, very common, calls them protons. So a proton is a positive charge in the nucleus, but quite unhelpfully, we also use the word proton to describe hydrogen with 1 positive charge. So the UPAC, the most proper name would be hydrogen ion, but the word proton is quite common. On the right hand side, you've got the anion. So you have the chloride anion, the chloride. You've got fluoride, and you've got oxide. And then you have what this table calls anionic groups, which are polyatomic ions that I mentioned in a previous slide. So the first one, this one here, NO3 minus, is the nitrate group. And this is worth remembering because it's quite common. Another one that is worth remembering is this one, OH minus, hydroxyl group. And when we're studying acid-base chemistry, we'll be looking a lot into OH minus and a lot into H pluses. So remembering hydrogen ions and remember hydroxyl ions is worth it. The next one, SiO4 minus, is silicates. And this one is also useful if you think of something like sulfuric acid, etc. Is the sulfate group, which I've chosen to write with the British English spelling of pH, but you will also see it as sulfate group with F if you're using the American spelling. And this one, CO3 minus 2 minus, sorry, is the carbonate group. And it's likely that we will spend a little bit of time when we're looking at acid-base chemistry talking about the carbonate chemistry, because it's quite a rich chemistry, and especially in environmental context, you know, the equilibrium of the different species of carbon dioxide and dissolving water, the carbonate group, is quite important in an environmental context. And the next one is borate, which is, you know, useful, but this one, PO43 minus, is the group, the phosphate group. And you might have heard about phosphoric acid, for example. Another couple that I think would be worth remembering is this one, Cr2O7, 2 minus, and this one, MnO4 minus. And this is called dichromate. And this is called permanganate. And the reason why I think is worth remembering is because the compound potassium dichromate and the compound potassium permanganate, the potassium salts, are particularly common as oxidizing agents in the lab. So you will probably be using it quite a lot, or you probably have already used it quite a lot in the lab, and definitely, well, this year and in years to come. So it's worth being familiar with the structure and the name so it doesn't surprise you when you're working in the lab.